Hi, this is Halal. In this video on Mathematical Economics series, we will solve a numerical on finding the profit maximization of a perfectly competitive firm. The question is, a perfectly competitive firm faces price is equal to 4 and total cost is given as that is q cube minus 7q square plus 12q plus 5 where q is the quantity. Find the best level of output of the firm. Also find the maximum profit. We have to find the maximum profit and optimal level of output for this very perfectly competitive firm. First of all, as we know, first order condition requires for the profit maximization. That is, first order condition requires that marginal revenue should be equal to marginal cost. So we will write marginal revenue should be equal to marginal cost. Okay, first of all, we will find the total revenue. Total revenue is simply, as we know, total revenue is equal to price times quantity. Okay, now our price is given, the firm is facing this P is equal to 4, so this is equal to 4 times Q. So the total revenue of the firm is 4Q. Okay, from their total revenue, we will find the marginal revenue. So finding marginal revenue is simply taking the derivative of the total revenue with respect to the quantity. So marginal revenue is simply the first derivative of total revenue with respect to quantity, that is dq, which is equal to, so we differentiate this 4q with respect to q. Here the derivative of q, as we know, is always equal to 1. So this is 4 times 1 is 4. So our marginal revenue is 4. Okay. Now we will see our total cost function is also given. So we will write the total cost function. Our total cost function is given as q cube minus 7q square plus 12q plus 5. This is our total cost. From the total cost, we will find the marginal cost, which is simply the first derivative of total cost function with respect to quantity. So our marginal cost is nothing but the derivative of total cost function with respect to quantity. So this is, we have to simply differentiate this cost function with respect to q. Now derivative of q cube is 2q. 3 minus 1 is 2, so 3q square minus, here the 2 becomes coefficient, so 2 7s are 14. 14 q, derivative of q is 1, so I will write here 12. So this is our marginal cost. Okay, as we have told earlier, profit maximization requires first order condition is that marginal revenue should be equal to marginal cost. This is our marginal revenue. So sorry, it is here marginal cost. Our marginal revenue is this, marginal cost is this. We will equate these two. Okay, so marginal revenue is equal to 4, so I will write 4 should be equal to this very 2q square minus 14q plus 12. So this is the first order condition for profit maximization, that is marginal revenue should be equal to marginal cost. Now we will solve this very equation for q. So I will write here, I will write 2q, sorry, it is 3q here. It is 3q because this 3 becomes coefficient, so I will write 3. This is 3q square, so I will write here 3q square, 3q square minus 14q plus 12, and transposing this on the right hand side, so this is minus 4, it should be equal to 0. Now again 3q square minus 14q, now 12 minus 4 is 8 plus 8, it should be equal to 0. So we have here the quadratic equation. Rather, we will solve for q, we will factorize this very quadratic function. For factorization, as we know, how will we factorize, I will show you here. The factorization is used here by splitting the middle term. We will split the middle term. Okay, we should get sum of the two numbers should be equal to the coefficient of middle term, that is minus 14, and product of the same numbers should be equal to the constant term times the coefficient of first term, so that is 8 times 3 is equal to 24. This is the factorization principle. I guess you people know it very well. Now we have to put two numbers in such a way that sum of the two numbers should be equal to minus 14 and product of the same number should be equal to 24. Let us think about this. If we take here minus 12, minus 2, now minus 12 plus minus 2 is equal to minus 14, and minus 12 into minus 2 is equal to plus 24, because minus times minus is plus. So we will plug these two values, minus 12 and minus 2 in this. So this is 3q square. In place of 14q, I will write this minus 12q minus 12q minus 2q plus 8 should be equal to 0. Now factoring this out, factoring first two terms and then the next two, here 3 and q will be factored out. 3q, here we get q minus 4. Similarly, here we will take minus 2 common, so we will get here q minus 4. It should be equal to 0. Okay, I will rub this out. So we get here 3q minus 2, that is 3q minus 2 should be equal to 0, or q minus 4 should be equal to 0. Now this is q is equal to, transposing this will become 2 divided by 3, or we will get the value of q is equal to 4. So we get two values, q is equal to 2 by 3 and 4. Okay, so we get the two values of the q here. Now what will we do? This was the first order condition. Here we can see that two output levels satisfy the first order condition, that is at equilibrium, that is at marginal revenue is equal to marginal cost, our output is 2 by 3 and 4. Now to find the profit maximization output from these two, we will rather use the second order condition. Okay, we will use now second order condition. Sorry for the disturbance, it is actually the snow which is getting heavy and heavy on the roofs, and it is falling down the roofs. Okay, now our second order condition will, first of all I will just try to make the graph. So I will show you graphically further. Second order condition requires that at the equilibrium point, that is where marginal revenue is equal to marginal cost, the marginal cost must be rising. So I will show first graph, I will then rub this. If this is our marginal revenue, our price, this is the price axis and this is quantity axis. Here we have the marginal, let us say we have this is our marginal cost, this is our marginal revenue. So first order condition requires that marginal revenue should be equal to marginal cost. Here we can see marginal revenue and marginal costs are equal at 2 points, that is at this point and at this point. Okay, at this point our output level is 2 by 3, and at this intersection point our output level is 4. Okay, second order condition requires that the slope of the marginal cost should be positive at the intersection of the marginal revenue and marginal cost. Okay, for this we will use the second order condition. So that means at the intersection point, marginal revenue, where marginal revenue is equal to marginal cost must be rising. By rising marginal cost, we mean the slope of the marginal cost should be positive. So we will show it mathematically here. So I will rub this out. So we have to find the slope of the marginal cost now. So second order condition requires that slope of marginal cost should be positive at critical points. Our critical points are 2 by 3 and 4. Okay, that means we have to differentiate now the marginal cost curve. So since our marginal cost is given as, our marginal cost is equal to 3q square minus 14q plus 12. Now the slope of marginal cost is just taking the derivative of this function with respect to quantity. So d times mc divided by dq. This very expression, this tells us the slope of the marginal cost function. Now this 3 2s are 6q minus 14. Okay, that is slope of marginal cost should be positive at critical points. Now slope of marginal cost is this very function. Now we have to evaluate this the slope of the marginal cost, or the second derivative of the total cost, at the critical points to find the profit maximization condition. So now d mc divided by dq at q is equal to 2 by 3. We will see what will be here the slope. Now here it is 6, 2 by 3 minus 14. Here the value should be positive because slope of the marginal cost should be positive at the point where marginal revenue and marginal cost intersect each other. Here 6 2s are 12, 12 divided by 3 is 4, 4 minus 14 is minus 10, so it is minus 10, which is less than 0. Okay, so this quantity 2 by 3 will not maximize the profits. Now we will evaluate it at the second critical point, that is 4. Now that is d mc divided by dq when q is equal to 4. So we will see what will happen. 6 times 4 minus 14. Here 6 4s are 24 minus 14 is equal to 10, which is greater than 0, or which is positive. We have seen here the slope of the marginal cost is here positive because we get positive 10. So this very quantity q is equal to 4 will maximize the output level. Okay, now we have to find the total profit. Okay, so should I rub here something? So I will rub this out here. Now our maximum profit is, that is pi, our maximum profit is equal to total revenue minus total cost. Now profit is maximized when q is equal to 4, so we will put the value of q in these two equations. Now total revenue function is given as, that is 4, that is total revenue is where is the total revenue? Total revenue is 4q minus the total cost function is this q cube minus 7q square plus 12q minus 5. Okay, this is 4q minus q cube plus 7q square minus 12q plus 5. Sorry, it is here plus 5, so this will become, this is here minus 5. Okay, now 4q minus 12q, that is equal to minus 8q. Okay, minus q cube plus 7q square minus 5. So we will evaluate this at critical points. Now our profit maximization is q is equal to 4. Now putting these values here, this is minus 8 times 4, 8 times 4 minus 4 4s are 16, 4s are 64. So this is here 64 plus it is here 7. Now 4 4s are 16. 16 into 7 is 16 into 7, 6 are 42, 7 1s are 7, 8 9 10 11. So it is here 7 6 are 42, 7 1s are 7, 8 9 10 11. This is 112. So I will write it here 112 minus 5. Now solving further, this is 8 4s are, this is minus 32 minus 64 plus 112 minus 5. Okay, let us see what does this equation tells us. Now minus 32 and minus 64, this is 4 plus 6 is 8, so this is 8, and we have 6 plus 3, sorry, 4 plus 2 is 6, I just forget here. So 4 plus 6 is, sorry, 4 plus 2 is 6 and 6 plus 3 is 9. So this is minus 96, and this is minus 5 plus 112. Now minus 96 and minus 5, that is minus 101 plus 112. So this comes out to be 11. So our maximum profit is 11. Okay, now graphically what does this mean? First I will repeat this. We were told that a perfectly competitive firm faces price is equal to 4 and its total cost function was given, and we were told to find the optimal level of output and optimal or maximum profit. Okay, what we did here, first order condition, as we know, requires that marginal revenue should be equal to marginal cost. So we take the total revenue function. Total revenue is equal to price times quantity 4 times q. So marginal revenue is simply the derivative of the total revenue function. Okay, similarly we take the total cost function and takes its derivative with respect to q, gives us the marginal cost. After that we equate marginal revenue and marginal cost at equilibrium. We get the two values of the q, that is first at the equilibrium where marginal revenue is equal to marginal cost, q is equal to 2 by 3 and 4. So only one of the two values will maximize the profit. So which of these two values will maximize profit? For that we use the second order condition. Second order condition tells us that the slope of the marginal cost at a point where marginal revenue and marginal costs intersect, the slope should be positive or marginal cost should be rising. Okay, so I will show you here graphically. This means so give me some time. Graphically means if this is the graph, this is quantity, this is price. So this is our marginal revenue, that is P is equal to 4, and our marginal cost looks like this. Okay, now first order condition requires, first condition is marginal revenue should be equal to marginal cost. Second condition is marginal cost should be rising, that is marginal cost should be rising at equilibrium where marginal revenue is equal to marginal cost. Okay, we find the two outputs where marginal revenue is equal to marginal cost, that is where q is equal to 2 by 3 and q is equal to 4. Okay, from these two values we have to find the maximum level of profit. Which of these two values will satisfy the maximum profit? So at this point also we have marginal revenue is equal to marginal cost. At this point we have marginal revenue is equal to marginal cost. So first condition is satisfies at 2 points. That is when Q is equal to 2 by 3 and Q is equal to 4. At these two intersection points, marginal revenue is equal to marginal cost. But second order condition requires at the equilibrium point, marginal cost should be rising. That is where these intersect. Here we can see marginal cost is falling. At this point we can see marginal cost is rising. That means at the equilibrium point, slope of this curve should be positive. That is the slope, that means the dq, it should be positive. Okay, here the slope is negative, here the slope is not negative, here the slope is positive. We have to find mathematically this slope. Now second order condition requires slope of marginal cost should be positive at the critical point. For that we take the slope of this marginal cost, it is our marginal revenue, and we will we try to find where is the slope positive at the critical point. These Q is equal to 2 by 3 and 4. So first we take the Q is equal to 2 by 3. That is our marginal cost is this. We take its derivative, that is slope of the marginal cost is this. This is the slope of the marginal cost, and we evaluate this slope at the critical point. At first critical point we get the slope minus 10, which is negative. At the second critical point we get the slope 10. Here we get a positive slope. That means profit will be maximized at this second point where Q is equal to 4, where our output is 4. So we just, okay, after that we have to find the maximum profit. We know maximum profit is nothing but total revenue minus total cost. So we take total revenue, and from that we subtract the total cost. So profit when output is equal to 4, we evaluate at this at the Q is equal to 4, and after that we found out that our maximum profit is 11. I hope I make myself clear in this video. Actually it is very cold outside. It is the second snowfall session in our area. Thank you.